Hello dear students, welcome back to BYJU'S Exam Prep and I welcome all for this final session of C programming. This is the last session which we are doing for last 1 month, okay, from starting from August 1st. So this is the last class where we try to conclude the C programming, my dear friends. Of course, the series will be concluded but not C programming. We are going to continue with C programming in the future also. Hi Sharif Ladka, Suprabhat, Arshpreet, very good morning sir. Okay, I welcome all of you. Okay, today's lecture may be little lengthy but we will try to conclude it. Am I clear? At the earliest. And I welcome all for this final session of C programming. Today we are going to conclude the story sir. And this is about GATE Champion series. I think it is already started. Please do join. And it is starting from 25th August and it's like live GATE workshop. Hi, good morning, Gurleen Kaur. Very good morning, sir. 500 plus important questions will be covered. MCQs, MSQs and numerical answer type around important questions of all your branch subjects will be discussed. Yeah, it will be done. Arshpreet, it will be done. Okay, I'll do it. I'll try to complete it. Okay, but it is a final class. So let us try to conclude it properly, my dear friends. That's it. And this is about me. And please do join this particular Telegram group. Am I clear? And I want everyone to comment today how you enjoyed this particular class. Okay, this particular series. Please share this particular series with your friends who require this particular C programming, my dear friends. Okay, that is the story. This is a Telegram group. Please do join this particular Telegram group for notes, discussions, assignments and updates. Okay, there is 2 assignments which were left. I will give you the assignments leisurely. You will do it. Okay, thank you sir. No problem sir. This is structures and unions part 2, my dear friends. And before that, we already discussed about structures, arrays. Now let us understand how to pass. Okay, we already know how to pass normal variables by value as by reference. Now let us understand how to pass arrays to functions. Then we try to understand how to pass structures to functions. And then we try to understand what is known as dynamic memory allocation. Then we try to introduce the self-referential structures, which actually leads to what is known as linked list. And towards the end, I'll try to introduce types of pointers, how to read pointers, I'll tell you, and with that we'll conclude today's session, my dear friends. Okay, so that is the story of today, the final or the finale. So how you pass an array? See, my dear friend, by default variables are passed by value, but array name itself is a pointer. Array name itself is a pointer. So can you explain how to return? See, anything you return pointer, my dear friends, but if you are returning a local value, that is dangerous. If you are returning that is local value, that is very dangerous, my dear friends. Okay, so please see that you return normally the name only, but the one which holds that particular return value must be double pointer, or it should be holding that particular matrix type. That is the idea, my dear friends. Ramakrishna, good morning Adi, very good morning. So you can pass an array. These are the multiple ways of passing an array. You can write A and you can tell the length of the array, or you can simply ignore the length of the array and you can pass it sir, or you can simply say int star A. A pointer also can be sent, my dear friends. Yeah, static we use. Yes, we can use static. That is what I already told you earlier also. Even variable when you want to return, or the pointer to variable you want to return, make it static so that that variable is alive till the end of the program. That is available till the end of the program, my dear friends. Am I clear? Yeah. Now let us take one simple example. Min array. See, actually this is the function sir. This particular function we are passing the array. Array means what sir? The address of the array is passed to this particular function. And also I am sending size separately. See, suppose if you know size, you can directly use it, you can ignore this particular size, but what happens, the same functions can be used multiple times. In such cases, what they use is, they use a general methodology for defining the function. They use this general methodology where they pass the array and the size of the array also separately they pass it. Am I clear? So that size can be used for writing whatever requirement of that particular program, my dear friends. In this, I am finding minimum value of an array. What is this particular program aiming for? It is trying to find the minimum value of the array, my dear friends. Am I clear? Now look here, I just say 0th element of the array as the minimum. 0th element of the array as minimum, I'll take it. And I introduce an integer variable and which is initialized with 0, my dear friends. Now for I is equal to 1 to I less than size, what I am doing is, I check current minimum value is what's our A0. A0 is compared with A1. If suppose A0 is greater than A1, what should be minimum, sir? A1 must be minimum. So what happens? You update minimum with A1. That is array 1. A1 in the sense whatever name of the array, sir. ARR1. Am I clear? So this you continue for entire array, my dear friends. So this is the simple program, my dear friends. So what is happening here? We are having an array, say 3, 2, 7, 8, 1. So initially what is minimum, sir? Initially what is minimum? Minimum is A0, that is 3. Then what you do? You compare minimum with A1. Is it greater than, minimum is greater than 2? Minimum is greater than 2? Yes. Therefore minimum is updated with A1. Again you move here, because this loop will move from 1 to end of the array, my dear friends. Now again 2 is greater than 7? No problem. Again 2 is greater than 8? No problem. 2 is greater than 1? Yes. So minimum is updated with 1. So once you complete the story, what is happening, sir? Once you complete the story, what is happening? You got what is the minimum value, and that you can return, sir, because it is returning that particular value, my dear friends. Hi Ishtakur, very good morning, sir. This is the last session and I welcome all of you to the last session. And in today's class, we learn how to pass arrays, two-dimensional arrays and structures to the functions. Dynamic memory allocation we will try to understand. Then linked list in the sense how to create self-referential structures we try to understand. Towards the end, we conclude with types of pointers. So these are the topics for today, my dear friends. Am I clear? Now main function. See here, I is equal to 0, minimum is equal to 0, and I create a array of size 6 and I initialize the values of the array, my dear friends. Now what I do, I call this particular function. See what is sent here as an argument, sir? Simply nums. The name of the array if you send, it is enough. The name of the array if you send, it is enough, sir. Am I clear? So this ARR will contains, ARR is exactly same as this nums, my dear friends. So if you want to write num1 here, it is exactly same as writing ARR1 here, my dear friends. That is ARR and nums point to the same 1D array, my dear friends. Same 1D array, my dear friends. Am I clear? So the rest of the story is taken care by this particular function. So rest of the story is I am just printing the value whatever is written. This value is written and that is taken by this minimum, and I am printing that particular minimum value, my dear friends. Am I clear? So when you run this particular program, what will be the output for this particular array? Of course, for my array, the array which I given, the minimum value was 1. But for the given array, what is the minimum value, sir? For the given array, what is the minimum value? For the given array, what is the minimum value? So it starts with 40 minimum. 40 is greater than 51? Yes, no, no problem. 40 is greater than 7? Yes, therefore 7 becomes minimum. Like that, when you continue, 2 becomes the minimum value. So this particular function will return 2 as the minimum value, and that is printed, my dear friends. Very good. So simple output, it is minimum number is 2, my dear friends. Now this is a simple program. I think it's a gate question, my dear friends. Now he given this particular function, he is asking what is the return value of, program is given, what is the output of this particular program. Am I clear? So if you observe this, this is an array of size 6 whose elements are 12, 7, 13, 4, 11 and 6. Now what I am doing, sir, I am sending the array name. Array name is address of the array. Suppose the address of the array is say 100, sir. Starting address, starting memory location is 100. 100 with size is sent, my dear friends. So this particular function is called with address star a. You can do a without any values, arguments, you can do it, or you can send size also, my dear friend. There are 3 different ways of passing an array. All will refer to the same thing, the address of 0th location. So A will contain this particular address and you're calling with size 6, my dear friend. See, this is what you done. F106 you called it. Now what is this particular function is doing? Let us understand. If this value of n is less than or equal to 0, it will return 0. Otherwise what it will do? It will check whether the value at A, means A is presently pointing to this location, the value at A percentile 2 is equal to 0. What do you mean by percentile 2 is equal to 0, my dear friends? What do you mean by percentile 2 is equal to 0? What is the meaning of this block and what is the meaning of this block? A percentile 2 is equal to 0 means it is expecting answer. Even number. Yeah, if it is even, what it will do is this particular piece of code get executed. If it is odd, this particular piece of code executed. Means you are getting a recursive function. For even, this particular recursive function will be activated. For odd, this particular recursive function will be activated. Because the value at A is 12, which is even. Now this is 12, which is even initially. So this portion get executed. That is 12 plus again you are calling F A plus 1. See, A is this, means A plus 1 is next location, sir. Suppose the size of integer is 4 bytes. So F 104 n minus 1. Originally size is 6. Now it is called with size 5, my dear friends. Ramakrishna, your doubts will be discussed later. I am doing a particular topic. Okay, it is not a doubt section, it is a concept section. Okay, towards the end, if time permits, I will tell you, otherwise I will ignore your doubt. You already asked that particular doubt. Okay, just send the name and your array, your function should return double pointer. Then it will hold that particular fellow and automatically whatever value holds that will access that particular array, my dear friends. Is that clear? See, it is not for solving your doubts only. It is a concept section. I am discussing a particular problem. You know all these problems already? See, the problem is students never understand what is the class happening. They only worry about their problems. Here a particular activity is going on. Understand that. You can ask a doubt at the end, or there is a separate Telegram group. I also given my number. There also you can share that, where you can talk with me also. Am I clear? Now I am discussing a particular problem. In between you want me to talk this. Wait. Himmat se kaam lo. Right. Now 104 and 5. Now what happened? This particular location, A plus 1 means this location, the value is odd, then this piece of code get executed. Value at A is what, sir? 7. So now this will call 7 minus what happens? F 108, and what is the size, my dear friend? 4 now. Am I clear? Now again this F 108, okay, is called, means this location. Again it is odd, means this part get executed. That is, what is the value? 13 minus F 112, and size now is 3. Now at this location it is even, means this piece of code executed. That is, you call 4 plus F 116 and it is 2, my dear friends. Again this fellow call, next fellow 11 is odd, means this piece of code 11 minus F 120 and size is 1. Am I clear? Again at 120 this is 6, which is even, means 6 plus F 124 and 0. Once the value of n is 0, what it returns, sir? It returns the value 0, my dear friends. That is 6 plus 0 is returned. 6 plus 0 is returned. 6 plus 0 is returned here. That is 6 is returned. Now 11 minus 6 means how much is returned, sir? 5 is returned. Now 5 plus 4 is 9 returned. 13 minus 9 is 4 is returned. 7 minus 4 is 3 returned, and 12 plus 3, that is 5 value is returned, my dear friends. 5 value is returned. Is the idea clear? Yes or no? So this is the story, my dear friends. Am I clear? This is the story. So this is answer for this particular problem. So the correct answer for this problem is what, sir? 15 is the answer for this problem. Am I clear? So those who are already know these topics, try to quickly answer the question. See, without understanding one-dimensional array problem, you want to understand how to do two-dimensional array. Please answer this question first. If you want me to answer that particular question, you should have tried this problem. Are you verifying whether I am doing it correctly or not? Yes, sir. It's not yes, sir. You try and you put your answer there. Am I clear? You have to try and you try your answer there. Or when you are hearing, it's fine. Okay? Like that. Now look here, next problem. This is very interesting problem, sir. Gate question. Even previous one is gate question, sir. Please hear carefully. Now, here this is the main function, execution starts here, and you have this particular array of size 5. This is an array of size 5, my dear friend. I'll write this array here. Shall I write it here? Okay. Array is this 3, 5, 2, 6 and 4. Now you call this particular function. Okay, let us assume some size also, address also, let us say 100. You calling 100 5. That is size. Address and size is sent to this particular function. See, whatever address you send, see, you simply send A only. But what is happening here? P is a pointer which can hold the address. That is, originally this is A, now P can hold this particular address. Now this function will take care of the rest of the activity by recursion. So let us see how this particular recursion happens. I think, yeah, I have this particular space there, I'll do it. Okay. Now this particular array is here 3, 5, 2, 6, 4. This is your original array. Now P is the pointer, that is this particular function is called with this address and number of elements. See, address I am just assuming, sir. Okay, don't put in a quote, sir, send 100, but when I verified the address was different. Don't worry about it. I am just sending you a particular address. Okay, assuming 100 is the address and number of elements is 5. Now what is happening? As long as n is greater than 1, this piece of code execute. Otherwise, when n is less than or equal to 1, the return value will be 0, my dear friends. Now look here, because n value, that is size, is greater than 1, the second part get executed. In this you see, actually if you observe, original problem was maximum of these two fellows. He not given the code for this, sir. He just said that maximum returns maximum of those two values. Means, here if you observe, whatever is maximum of fp plus 1 and n minus 1 and p0 minus p1. P0 minus P1. That is, P is pointing to a particular location. No, P0 means the value at the location, P1 means next value. That is, the current value and next value difference, you find it, and the value returned by this particular function. Out of this, whatever is maximum, that is returned by this particular function, my dear friends. Yeah, P0, P1, yeah, obviously. Perfect, correct, Eddie, correct. Yes, you are correct. Super. Is the idea clear? Like this. F P plus 1 n minus 1 P0 is equal to P1. Sorry, P0 minus, sir, it's not equal to minus. That's what I am saying. Why equal to hidden? Minus it is. Am I clear? Now what is this F105? What it will do? See, here I written the maximum function, sir. What actually it will do is Fp plus 1 means F104 and size will be 4, and the other one is P0 minus P1. See, at this position P0 is 3, P1 is 5. 3 minus 5 is what, sir? 3 minus 5 is what? Minus 2. So, now once you get the function value, that is compared with minus 2, out of which whatever is maximum, that is returned by this function, sir. So, for that we need to know return value of this particular function. But it is a recursive function. First you have to complete the process. In the unwinding phase only, you can return maximum of these two values. So, first let us do the winding phase. So, F10 will call what, sir? It will call F108 with size 3, and at this position, because F108 means you are at this position. Now, P0 will be this and P1 will be this. That is, next two elements difference you are finding. 5 minus 2 means what, sir? 5 minus 2 means 3. Now, again this particular function value and that 3 need to be compared. Whatever is maximum, that is returned. Now, again this will call F112. I am assuming size of the integer is 4 bytes, then 2, and here now you are doing 2 minus 6, the next two values, because p is moving now, here it is p is moved to p plus 1, now p is here, now p is here, like this. So what is happening here? 2 minus 6 is minus 4. That is next two values you are going to find. Now again it calls F114 and it is 114 and 1, and what is this? 6 minus 4, which is minus. 6 minus 4 is plus 2 na? 6 minus 4 is plus 2. Is it clear? Now once you reach the 1, when it is 1, the function returns the value 0, sir. The function returns the value 0. Now you have to compare 0 to, you have to compare 0 to, sir. Out of 0 to, which one is maximum? 2 is maximum, 2 is returned. Now 2 minus 4, which one is maximum? 2 is maximum, 2 is returned. Out of 2, 3, which one is maximum? 3 is maximum, so 3 is returned. Now out of 3 minus 2, which one is maximum? 3 is maximum, so 3 is returned, my dear friends. See, of course you can do this way. This is complete elaborate work, my dear friends. But actually what this particular function is doing is two adjacent values difference. Out of that, what is maximum? That is returning. That is two adjacent values of the array. It is finding the difference of two adjacent values of the array. Out of the two adjacent values different, whatever is maximum, that is returned by this particular function. So if you see 3 minus 5 is what, sir? Minus 2. 5 minus 2 is what, sir? 3. 2 minus 6 is what, sir? Minus 4. 6 minus 4 is 2. Out of this, what is the maximum difference between adjacent elements of the array? What is the maximum difference between adjacent elements of the array? What is the maximum difference? 3. So this particular function is actually finding the maximum difference between adjacent elements of an array. If you understand, you don't have to do all this nonsense, sir. Directly I answer this question 3 here itself by understanding this logic. What it is doing? Two adjacent elements, because dynamically, as our AD said, dynamically p is moving, no? So every time it is finding two adjacent element difference. Next time also two adjacent elements difference, two adjacent elements difference, because function is called with next memory location, no? Now p changes to next location means next location and next location difference. So we are finding difference of adjacent locations, out of that the maximum is returned by this particular function. Am I clear? So it will return maximum difference between adjacent elements of an array. If you understand, directly you can answer this. Even otherwise, with this recursion process also, you can answer this question, my dear friends. You can answer this particular question, my dear friends. Is the idea clear? Is the idea clear? Super. Some people tried, and Ramakrishna, you said 2. Am I clear? That is wrong. It was 3. Am I clear? Later you changed the answer. Acha, you are giving answers regularly. What happens the difference? Okay. I think you are giving what is this answer, what is this answer. This you might be giving. Then it's fine. I am sorry. I thought you given final answer. No. It's clear now? Very good. So 3 will be the answer for this. If you run this code, you will get 3 answers. Of course, actually in the given problem, you cannot directly run, sir. For that, you have to define a maximum function also. So for simplicity, I just written the maximum function here. So that you can execute and verify. Am I clear? That's how I got this particular answer, my dear friends. Is the idea clear? Now passing 2D arrays to function. My dear friends. See, we can pass 2D array. How you can say? See, here also the address is sent. And remember, if it is 1D array, the name of the array is 0th location. But when it is 2D array, what is the name of the array, my dear friends? Name of the array is actually referred to the 0th 1D array. Name of the array refers to 0th 1D array. ARR plus 1 means next 1D array, my dear friends. Now here, that particular address is sent here. So when you send, you can send the complete name, that is size of number of rows, number of columns, you can send it, or you can ignore the number of rows, my dear friends. You can ignore the number of rows, you can just, but number of columns cannot be ignored, my dear friends. Number of columns cannot be ignored. This number of rows part can be ignored. Or ARR 0 0 will be this particular element, my dear friends. Am I clear? Or there is one more way, we can define it as a pointer to an array of 4 integers. Pointer to an array of 4 integers. See, originally your array will be, see how the function is called. Function is called like, you know, suppose your ARR is array is that, see your array is say ARR 3 4. This is your array. Some initialization may be happening and you want to call this particular function with ARR, you can simply say F1 ARR, sir. Just ARR is enough. ARR means that particular address. Am I clear? So this A also refers to the same address. A also refers to what, sir? This particular address. See, in one dimensional array, like star A can refer to star A if you do it. That is only star A if you do it, it is enough. This can point to this particular location because you are just pointing to a, you are just pointing to what, sir? You are just pointing to a single integer location. That A plus 1 will point to the next location. Whereas here what this fellow should do, sir? A should point to, A is a pointer to an array of 4 integers. A is a pointer and this fellow contain the first particular array. This fellow contain address of second particular array and this fellow contain address of third particular array, like this, my dear friends. So this is how the story will move, my dear friends. Hello, sir. Array of pointers. Okay. It is pointer to, A is a pointer to an array of 4 integers. It's not array of pointers, sir. Array of pointers is different. This is array of pointers. This is array of pointers. It is pointer to an array of 4 integers. Pointer to single fellow will do the entire story. Na? Single fellow should do entire business. Separate pointer should not do it. Single fellow should do the entire business. So this is pointer to this particular array of 4 integers. When you have this A0 means this location. A0 is this location. And A0, and if you want to access this particular array, A01 is this location. A02 is the next location, like that it happens, and this refers to A1, my dear friends. This refers to A1 and this refers to A10, this refers to A12, like that it happens. Okay, so this is the story, my dear friends. I think Ramakrishna, if you understand this, written also same way it happens. Written also same way it happens. You send that ARR, that will be taken care by such a pointer which can hold, am I clear, that particular address of a 2-dimensional array. So you just send address, sir, and we should have a pointer which can hold address of a 2-dimensional array. Am I clear? Like that it can be done, my dear friends. Am I clear? So I'll just give you a simple example. Okay, I'll just give you a simple example where I create a 2-dimensional array and I print a 2-dimensional array. I create a 2-dimensional array and I print a 2-dimensional array using functions. Using functions, I create a 2-dimensional array and I print a 2-dimensional array. So look here, this is for rows number and column number. I am using hash define constants, sir. Of course, there hash include also given here. Hash define R, capital R denote number of rows, capital C denote number of columns. Here I taken 3 4. Later on, if you want to change that, you can change 3 4 to different numbers and you can practice this problem, my dear friends. Now look here, there is a scan matrix. Now what is the argument taken by this, sir? What is the argument taken by this? See, if you want, you can simply say M R C, you can write it, or you can say M C, you can do it, or you can do star M C, you can do it. Star M C, you can do it. These are the different arguments possible, sir. Here in the place of this, you can do this, you can do this, or you can do this, my dear friends. Even double pointer also can be done, but that is used generally with dynamically allocated memory, my dear friends. That is generally used with dynamically allocated memory, my dear friends. Am I clear? Please remember that. Now look here, print matrix also will have same argument. What is the argument, sir? We are passing 2-dimensional array. What we are passing, sir? We are passing 2-dimensional array to this. Now here this is a matrix of size 3 by 4 matrix. I is an integer variable, j is an integer variable. Printf, enter the elements of the matrix row wise. Row wise we are asking you to enter how many rows, sir? 3 rows and 4 columns. Now you call the scan matrix. What scan matrix will do, let us see, and what print matrix do, let us see. See, this is a scan matrix function, my dear friends, and you pass this. See, my dear friends, your original array is mat. This is your original 2-dimensional matrix. It is your original 2-dimensional matrix, my dear friends. See, mat is actually referring to what? First 1D array. then mat plus 1 will be next 1D array, like that it is going. It is 3 by 4, no? So it is each array will contain 4 elements, my dear friends. So this is the story of mat. Now this M will refer to same as this mat, my dear friend. M will refer to the same. M and mat are one and the same. M and mat are one and the same. Am I clear? So this fellow also refers to what, sir? M is a pointer to, M is what, sir? A pointer to an integer of, M is a pointer to an array of 4 integers. Mat is also what? It is a pointer to an array of 4 integers. See, mat is also pointer to an array of 4 integers. M is also what? It is also a pointer to 4 integers. So both are referring to the same story, sir. So whatever nonsense you want to do with mat, the same nonsense you can do with M also. Same nonsense you can also do with M, my dear friends. Am I clear? Am I clear? See, so earlier you used to write ampersand mat ij scan the elements. Ampersand means address. When you send address, at the address using scan function, you can input the values, my dear friends. And now same story with print matrix. What is the argument, sir? 2-dimensional array. Pointer to 2-dimensional array. Pointer to 2-dimensional array. Am I clear? See, the name of 2-dimensional array is what actually it is pointer to first 1D array. I mean 0th 1D array. Similarly, M is also what, sir? Pointer to an array of 4 integers. Same story. Array of C integers. C is the value, means whatever. C is 4, no? So that's why I am saying 4 integers. Is the idea clear? So this is how we can call print matrix, my dear friends. Now what it will do, sir? I is equal to 0, I less than R, J is equal to 0, J less than C. Now what you are doing? I am just printing Mij value, my dear friends. It is exactly same as doing, suppose within the function, if you want to do it, you can do the same story with replacing M with mat, my dear friend. M and mat are referring to the same story. Hi AB de Villiers, very good morning, sir. Is the mechanism clear to you all? Is the idea clear to you all? How to pass a 2D array? Is that clear to you all, or any doubts? Is it clear or any doubts? See, my dear friends, when it is 1D array, how you pass, my dear friends? You can pass, suppose this is the function name, how you can pass an array? Array name, without any argument you can pass it, or you can pass array name with size, you can pass it, or you can pass just pointer, my dear friends. So what is A here? It is pointer to an integer. See, actually in your original function it may be ARR of say size 5. ARR is what actually? ARR is actually pointer to 0th location, which is pointer to an integer. So here also we should have a pointer to an integer, my dear friends. The argument, formal parameter also must be a pointer to an integer. Because original ARR is pointer to an integer, this is actual argument. See, this is how you call it. Fun ARR you call it. See, this is actual argument. What is actual argument? It is a pointer to an integer. So this formal argument, formal parameter also must be pointer to an integer. Whereas in 2D array, if you see this is a 2-dimensional array, say mat with say 3 rows and 4 columns. What is mat actually, sir? Mat is actually a pointer to a 1D array of size 4. 1D array of size 4. Okay, that macro is used. I am just writing 3, 4, sir. Okay, you can write 3, 4 or whatever numbers. I am just trying to explain the idea. Mat is a pointer to an array of 4 integers. See, you call this function with mat, that is you want to send this mat as an argument to the function. So what is the argument to the function, sir? It is a pointer to an array of 4 integers. So whatever is the formal parameter, that also must be a pointer to 4 integers. So when you call this particular function, whatever function you call it, the argument must be what? It should be a pointer to an array of 4 integers. So therefore mat refers to pointer to an array of 4 integers. Even this M refers to pointer to an array of 4 integers. So they should match with each other. That is the logic, my dear friends. The formal parameter and actual parameters, they must be of same type. They cannot be of different types. That is the main idea, my dear friends, when you pass an array to the function. See, the logic here is very simple, sir. Whatever argument you send, the argument type and formal parameter type must be same. When you are sending 1D array, the name of 1D array is pointer to an integer. So here formal parameter also must be a pointer to an integer. What can be pointer to integer, sir? If you do it, it is a pointer to integer. If you do with size also, it is pointer to integer. If you do star A, it is also pointer to integer. Similarly, when you do two-dimensional array, mat is actually pointer to 0th 1D array. 0th 1D array means how many elements are there in this? 4. That is, it is a pointer to an array of 4 integers. So because mat is a pointer to an array of 4 integers, which is actual argument, the formal argument also must be a pointer to an array of 4 integers. So this is the logic, my dear friends. Later on, whether you do with structures or whatever you do it, whatever is the type of actual argument, the formal parameter also must be of same type. This logic, if you understand, you will never do mistakes in this, my dear friends. So that is the moral of the story. That is the moral of the story. Am I clear? Is the idea clear? मैट प्लस 1 करेंगे, कहाँ करेंगे मैट प्लस 1? मैट प्लस 1 करेंगे तो सी द सेकेंड 2D एरे पास हो जाएगा. सेकेंड 2D एरे का जो second 1D array, because mat is pointed to first 1D array. Mat plus 1 means next 1D array. So next 1D array will be passed as argument to the function. So M0 will be pointing to the first 1D array, my dear friends. It points to the next 1D array. That's it. Like that. Is that clear? Of course, if you run this particular program, that would be the output, sir. Hope you understand this story. Hope you understand this story. Yes or no? Yeah. Now structures and functions. See, whether it is sending simple integer argument or sending simple regular data types or pointers or matrices or arrays or structures, the idea is same. Whatever you send, the fellow which actually referring to that must be of same type. So the actual argument type and formal parameter type must be matching. That is the simple logic. Those who understand will never do any mistake in this. The actual argument type and formal argument type must be same. They must be of same type. That is the logic, sir. If you understand, I don't mind whether it is sending simple integer variable, pointer to an integer variable, passing an array, passing two-dimensional array, passing structure, or passing only one element of a structure or pointer to structure. It does not matter for me. Everything is same for me. Am I clear? Everything is same for me because actual argument type and formal argument type must be same. Because when you send this, whatever is holding that must be of same type. That must be of same type. That is the basic idea. Am I clear? Thank you, sir. Now structures may be passed as argument to functions in different ways. Am I clear? We can pass individual members, whole structure variable or structure pointers also. See, anything can be passed to functions, sir. See, if you pass individual variable, the formal parameters must be individual variable types. If you send the entire structure, the formal parameters must be structure type. If you send pointer to structure type, the formal parameters must be pointer to structure type. Then that can hold whatever business you are doing here, the same business can be done here with that formal parameters. Whatever actual arguments are doing, the same story can be done by formal parameters. 500 plus questions, we do not know, sir, how much time it takes, around 1 month or 1.5 months, I think. Okay, not exactly known for that particular value, sir, but that is the logic. Okay, right. Similarly, a function can return, it can return a structure member. See, when you are returning also, whatever you are returning, the fellow which is holding, that is when you return something, the fellow which is holding must be of the same type. So function, when you return, see, function is returning integer, the return type of function must be integer. Function is returning pointer to an integer, the return type of function must be an integer pointer. And the value which takes that particular fellow also must be of same type. The fellow which takes this particular value, see after returning that you may be assigning to some fellow, that fellow also must be of same type, or you need to do typecasting there, So the logic is same, my dear friends. The logic is same, my dear friends. Hope you understand. So you can send anything, but the type must be same. You can return anything, but whatever you are returning by function, you should mention in the function return type. Function return type, you have to mention what you are returning, and whatever value which is you are assigning this return type, that must be of same type, or it must be done typecasting, for that. That is the logic. Now individual structure members can be passed as arguments. See, individual structure members are what, sir? For example, I am having a structure with a character, a float and an integer. So individual structure members, of course, even though they are structure members, once you write like s1 dot a, it may be representing that particular character. So you are just sending a character. Suppose s1 dot I may be integer, so you are just sending an integer. s1 dot f may be float, you are just sending a float. Am I clear? Thank you, sir. Thank you, Akil Kumar. Thank you. Now this is your hash include stdio.h type def struct. Now look here, I created a structure definition. Student structure definition is done. Here it is only a data type. I created a student data type. Here student data type created. Here student data type is created. Am I clear? Thank you, AB Delivers. Now look here, this is a function. See, what are the arguments of this particular function? An array, an integer and an integer. So 3 arguments are there. First one is an array. So you have to pass an array, one dimensional array. Second one is roll number, that is integer. You have to pass an integer. Third, you have to pass an integer. So that's it. Suppose you want to call this particular function display, first argument must be array type, second argument must be integer type, third argument must be integer type, then automatically this function get called, and whatever business it is doing, it will take care of that, my dear friends. Okay, this what is doing? I am just printing this name, I am printing this roll number, I am printing this marks, my dear friends. I am printing this particular marks. Now look here, I created a variable of s1 type and I initialized. So this array, this structure is created which is having 3 fields. First one is, what is the first one, sir? It's a character array or a string. It should end with \0. Next one is integer, which is 1001. Next one is integer, which is 500. Now look here, what I am sending as argument to this particular display function. I am sending as an argument s1.name. See, it may look like s1.name, but s1.name is just an array, sir, or a character array. That is a string. I am sending a string and it is holding that particular string. No problem. And I am sending s1.roll number, that is roll number is passed and that is taken care by an integer variable. That is fine. I send s1.marks, that is taken care by this marks. So I am just printing this name, roll number and marks. That is get printed, my dear friends. Name is Raju, very good. Name Raju is printed. Roll number is 1001 is printed. Marks is 500 is printed. Yes. So that is the story, my dear friend. Name Raju, roll number 1001, marks 500, my dear friends. That is the story. Hope you understand. Super, super. So you can pass an array, you can pass an integer, you can pass an structure members. Here I am passing structure members. What I am passing here, sir? Structure members are passed. Structure, I think here he written no, passing structure members as an argument. Here I clearly written that. Am I clear? Structure members are passed. No need of writing again. Hope you understand. Very good, Arshprit. Very, very good. Super cool. Wonderful. 100%. Now you can send structure variable as, that is entire structure can be sent as an argument. But whatever is holding that, that also must be a structure variable. That also must be a structure variable. So when there are many members, then passing individual members may be costly business. Therefore, what we can do? We can send entire structure as an argument to the function, my dear friends. Because here we have 3 arguments. You have to send every member separately. Very costly business. Suppose my structure is having 10 members. I need to pass 10 arguments. Very costly business. So don't worry, instead of sending individual fellows, send the entire structure at once. Send entire structure at once. Again remember, whenever you send whether individual members or entire structure, only copy is sent. Default is copy, sir. Only with arrays, because the name of the array is pointer, there directly address is sent. With arrays what happens? Directly address is sent. Rest of the story is just that particular copy is sent, my dear friends. Please remember. Of course, in that particular structure, if there is a character array, that particular address is sent, sir. Am I clear? So that is the idea. Now let us see this. Of course, this is small t, sir. Type def struct. So I created a student data type. Now this is displayed. Now this time I am sending only a variable of, what is the argument, sir? Structure type argument. SE structure type argument. So in the main function, S1 is created. I simply send S1 copy. So S refers to the same S1. So instead of here doing S1.Raju or S1.name, okay, S1.roll number and S1.marks, here you can simply do, because S refers to S1, no, S1.name, S.name, S.roll number, S.marks, you can do it, and it also gives the same output, my dear friend. See, it looks very compact, no? Compared to the previous one, it looks very compact, correct or not? So that is the advantage of doing. When you have multiple members, instead of sending individual members, you can send entire structure also as an argument, my dear friends. Passing pointer to structure, even you can pass. Thank you, sir. Thank you, Sirisha. Thank you. Okay. Passing pointers to structure as argument. Okay. Now you can also pass, like, just like you know, you pass integer pointers, you can pass structure pointers also as an argument. If the size of structure is very large, then it is not efficient to pass whole structure, because entire copy need to be sent. That is, this structure size is say 100. The same 100 size need 100 bytes, same 100 bytes need to be copied again. So that is again a costly business. Instead of sending the entire copy, send the address, manipulate that. That is the idea. To the function, since a copy of it must be made inside the called function. Am I clear? So when you send the entire structure, copy need to be made for the function also. That is a costly business. Instead of that, what we can do? We can simply send the address, my dear friends. See, it is simply same as passing pointer to an integer variable, pointer to a structure variable, you are sending it. Yeah. See, the member of structure variable can be accessed inside the calling function using right arrow operator. Of course, it should be called as right arrow operator. Of course, default arrow is right arrow only, na? So right arrow operator. We can access them using right arrow operator. In this case, any changes made to the structure variable inside, see, obviously, when it is pass by reference or call by reference, what happens? Whatever changes made to the formal arguments will affect actual arguments. Okay. See, it is because I am giving the notes for future reference, for notes purpose, I am just giving the points. The logic is very simple. If structure size is big, if you send it, what happen? It would be costly effect, because you have to copy 100 bytes, means 100 bytes you have to copy again. Suppose 10 functions are called, 10 into 100, 1000 bytes will be copied. That would be very costly. And again, if it is a recursion, it is very costly. Am I clear? So in such cases, instead of sending the copy, send the address. So when you send the address, it is called by reference. Whatever changes made to the formal parameters affect the actual parameters, my dear friends, because it is same as call by reference. It is same as call by reference. Now again, I created a student data type, same student data type I am using, sir. See, this time what I am sending, sir? I am sending argument is what, sir? Pointer to student type. Pointer to student type. See here, S1 is a student type of structure, my dear friend. S1 is a student type of structure which is having this Raju fellow, 1001, and this 500. See, if you don't like Raju, you can change it to some other fellow, sir. No problem. I just give, regular Telugu names. Okay, you can use different names, my dear friends. Okay. Now what happens? S1. P is containing address of S1. P is containing address of S1. Now this P, of course, this P and this P we use same name, but this is actually P of function. So this P, which is P of function, will contain this particular address, because you are sending P as an argument. So we are having this P as address. So whenever you have this pointer to, this is P is pointer to this particular structure. How can you access the members, sir? If it is a pointer, we have to access the members like star P dot name. But instead of doing this star and dot, okay, because this is used very regularly, so they created a new operator for this which can do the same effect, which is right arrow operator. The right arrow operator will do the same business as the star p dot name. And please remember here, sir, the parenthesis for star p is compulsory because dot operator is having what? Dot operator is having I think they are having same precedence, na? Yeah, sorry, I think it's not necessary. For this, it's not necessary. Star p dot name, it's fine. I think star p will work, na? Star and p, they are both are primary operators. Star and dot will be primary operator, left to right associative. So obviously it will take star p dot name can be done. Star p dot name can be done. Which one is having higher precedence than star, sir? See, primary, you know, they are all primary only. They are all primary only, na? Star has more. So obviously star has more means star p will be taken, sir, but star is not having more. See, primary operators are this fellow, star, dot, right arrow operator, all these are primary operators. And even I'm sorry, the postfix expressions, the postfix fellows are also having higher precedence. Is star is a unary operator? Star is a unary operator? Star is a unary operator? Okay. If dot has more precedence, then you have to put this parenthesis, my dear friend. I think this is having higher precedence, then you have to put this parenthesis. Yeah. Do it. Primary operators, what are the primary operators, sir? What are the primary operators? This fellow, dot, right arrow, postfix plus, postfix minus, postfix increment, postfix decrement. Then these are primary operator. I think unary operators are unary plus, unary minus. This star also unary operator. Okay. Then this fellow will be having lower precedence than dot, because dot is having higher precedence. You have to use the one. Am I clear? So please use this, my dear. But this would be confusing. That's why I use this arrow operator for this, my dear friend. P right arrow operator name. Am I clear? Yeah. Correct only. Okay. I was thinking otherwise. Nice. Correct only. See, whether I told you or someone told, don't worry about it, sir. Just see the operators. In the primary, this one, you know, what is this? The operators precedence table. In the primary, what are the operators you are having? Just go through that. Whether I told or someone told, don't believe, sir. In C language, you need to remember that particular order of precedence and what all comes under primary and what all comes under unary. That is important. Am I clear? Yeah. Am I clear? Just see what are the primary. I think unary, star is unary operator. Then this fellow has less operator. This is left to right associative. These fellows are right to left associative, my dear friends. Okay. The prefix, the postfix, prefix increment and prefix decrement, all these are in the next level, my dear friends. Okay. Just see this. I want all of you just verify this once. You just verify this. Then it automatically get fixed, sir. You don't have to worry about it. Am I clear? Hope you understand. Yeah. So the same story happens, my dear friends. So instead of this P right arrow name, you can do star P name, my dear friends. Star P dot name, my dear friends. Star P dot name. See, generally I don't remember this many things, sir. I just follow logic. Okay. So with the logic, things would be more clear, sir. Okay, we can solve. Only thing is we need to practice this precedence of operators properly. If it goes here and there, then you are in trouble. So you have to practice that precedence operators properly, my dear friends. Am I clear? Like this. So hope you understand this idea. Yes or no? Next one is returning a structure variable from function. You can also return a structure variable from function, my dear friend, but returning anything from a function, because that is a local variable, after function that fellow will be erased. So copy, if you send, that can be taken by some fellow, can be used, but returning pointers are very dangerous. Please remember, the copies can be returned, my dear friend. Copies can be returned because only copy is sent, that copy can be stored somewhere, because we don't need original variables there. But when you are returning pointers, you have to be careful. But returning structure variable is regular, no problem, my dear friends. Structure variables can be written from functions as any other integer variable. Structure variable also can be sent or returned from a function, my dear friend. But the return type of function must be that particular structure type. The return type of function must be that particular function type. Am I clear? Like that. That's second statement. The return value can be assigned to a structure of appropriated. That is normal. Now look here. Of course, we created a data type, student data type. This is a get data. See, this fellow get data is a function which returns student type, my dear friends. Now what is that? I created a student data type, student structure or variable of student data type. I created a yes, which is a variable of student data type, and which is initialized with Raju, which is a string, 1001 which is an integer, 500 which is an integer, my dear friends. Return S. See, we can return, no problem. See here, if you use static, what happens next time? The same values will be remembered. But when you are just returning copy, don't have to worry about it, sir. Functions can return copies, no problem. Because after sending the Xerox copy, if even original fellow dies, we don't mind. Original fellows why? We don't mind, sir. We will try, sir. Let me complete one after the other. Please do join my Telegram group. Okay, this is here. We'll update things for sure. Okay. So student S1 is equal to get data. So I created a variable S1. What is the value I am assigning? Using this, I created the values, and that values are written, and that copy is assigned to S1. That copy is assigned to S1, my dear friends. Am I clear? Now what you do after assigning this S1 is your structure type only. S1 dot name, S1 dot roll number, S1 dot marks you can print, my dear friends, and it will do the same business, my dear friends. It will do the same business. Now returning a pointer to structure from function. So whenever you return pointers, now you need to return pointers, make sure that the pointer which you are returning, okay, or the variable of the pointer of the variable which you are returning must be of a static type or a global type. That is better. If that is of local type, once you go out of the function, okay, the value will be erased, my dear friends, and the return value or the output which you are going to get is unpredictable. Okay, so please be careful. Whenever you need to return pointer of a particular variable from a function, you see that that particular variable is of static type, then it is not dangerous, or it is of global type, then also it is of not dangerous, my dear friends. If it is of local type variable or automatic variable, if you return the pointer to that fellow, maybe you may get some result at particular time, but what happens when you have such recursive functions, that function may be replaced with something else, and that particular value, maybe some other value may be stored, and you are referring to that particular value. So you have to be very careful. You are actually referring to the address of a particular location, sir. So you have to be very careful. Am I clear? Now look here, I created a student data type. See here, this get data returns pointer to an integer. This function returns pointer to student type. It returns pointer to a student type. Now look here, I created a student variable S and I made it static. Why, sir? Because I am returning the pointer to this fellow. When I go out of this particular function, it should not die. So static variables are stored in which segment of the memory, my dear friends? Wow. Thank you, sir. Thank you very much. Don't make such comments, sir. It's fine. Learn things. Thank you. Okay. So S is what, sir? S is a structure variable you created, and if you make it static, in which memory location it is stored, sir? In which memory location it is stored, sir? Static variables are stored in which memory location? See, if I am best, you should answer the best. Otherwise, people feel that, okay, I am asking you to comment in my sessions. Okay, data segment. Now people feel, okay, you are a good student, real student. Okay, yeah, data segment. Am I clear? Yeah. Is that clear? Static. stored in data segment. It will not be erased once the function goes out of the memory. Am I clear? Is very good, Prajwal, very good. Now look here, I created a pointer to student data type. P is equal to get data, because this get data function is returning pointer, no? So that is taken by this P. Now using P, how can you access the member, sir? Of course, star P name, star P, what is it, roll number, star P marks, dot marks. That way you can do it, or we have a beautiful right arrow operator. So a simple story about right arrow operator. Okay, I think it is not given here, maybe in the next slide I given. I'll tell you. So this is about right arrow operator, we can use it, sir. Either you can use this or you can use simply right arrow operator for this, right arrow operator for this. Am I clear? Now array of structures can be passed as an argument to function. See, just like you pass a structure variable, you can pass an array of structures also. Just like you can send an array of integers. We have already seen how to pass an array of integers. We can pass an array of structures also. An array of structures also can be passed as an argument to the function. Okay, so let us see this. So we created a student data type. See here what is passed as an argument. Array of STD is an array of students. Size need not be sent, my dear friends. Okay, it's directly STD is a pointer. So the argument which you send is the name of the array, which is also pointer to that particular array. So STD also will point to that particular array. Just like the original array, whatever is there, this STD also can be used to access that particular array, my dear friends. But it is little interesting, so let us see this carefully, sir. Look here, we created an array of 3 students. We created an array of 3 students. Actually, type def means this is not necessary, sir, because we not given, it may pose an error. Please remove this. This is an error. STD is an array of 3 student data types. STD is an array of 3 student data types. What I am doing, sir, for every fellow, for I is equal to 0, I is equal to 1, I is equal to 2, I am just printing the values, my dear friends. See what I am doing. For I is equal to 0, enter the name, roll number and marks of the students, my dear friends. Enter the name, roll number and marks of the student. See, for each fellow, na, see it is an array of 3 students, no? STD 0, the members, STD 0, the members I have to initialize. So it is STD 0 dot name, STD 0 dot name, STD 0 dot roll number, STD 0 dot marks. So what happens? Using scanf function, I am storing the value, my dear friend. Using scanning function, I am storing the value, my dear friends. Similarly, using scanf function, I am storing the value. See, this I do it for STD0, this I do it for STD1, this I do it for STD2, my dear friends. Now, what I am doing after creating it, I am using this display function. What I sent for this? The array name. STD is sent as an argument. So, using this STD, I am printing it. Actually, just like you are doing display, right? Even you can create a function called create function. There also you can send this STD. Even scanning also can be done in a separate function, my dear friends. I want everyone to try that. I want everyone to write a separate function for this scanf also. You call it as some create function. You please create function. You please write a create function for the same, my dear friends. See, any array is automatically pointer, my dear friends. So when you send an array means you are actually sending the pointer. Am I clear? Where you want to write student star STD? Yeah, here you can write student star STD can be written. Yes, you can write student star STD can be written. Yeah, very good. Correct. Super. You people are rocking, sir. Okay. People know much better and you are rocking. Now I want everyone to write a function like display. I want you to write a function create function, sir. I want you to write a create function just like a display function for the same. That is homework. Either you can write in the comment section or you can write this in your Telegram group. Okay, like this. So when you run this, you get this particular program, my dear friends. So I enter Raju, roll number 100, marks 84, Ravi, roll number 101, 96 marks. The third fellow, Ramu, roll number 102, 87. After that, using display, I printed that. Raju 100, 84, Ravi 101, 96, Ramu 102, 87. Is the idea clear? Is the idea clear? See, any variable, whether it is integer variable, structure variable, or new data type variable created by structure, you just see it as just a variable. If you see how to access the members, if it is normal integer, you just access that variable. If it is a structure variable member, the name dot that fellow, you have to do it. If it is a pointer to a structure variable, how to access the member? This fellow, arrow that fellow. That is how we access the members, my dear friends. Please remember that idea, my dear friends. Am I clear? Hope you understand. Yes or no? Okay, let us take this particular example, sir. It's a GATE question. It's a GATE question. Let us solve this. Let us try this. A big question, sir. I think some part might be missing here. Maybe covering some part. No. Yeah. I think you can see the last part, P arrow A and P arrow B. Now look here. This is the option for this. What I do is I will simplify what is required. I will write it so that I have some space. I can solve the problem here. So same problem I written separately, my dear friend. Unnecessary things I removed. Now look here. I have a static. See, we created what, sir? First you need to understand. We created a. First what we done? We created a data type. Am I clear? Type def strap. Directly you are creating the variable, then you don't have to write the name also. You created, you created a data type whose name is T. And what are the members, my dear friends? The character pointers. The members are character pointers for this T, my dear friends. So T is the data type. You created a data type. Now let us move to the function. See, in the main function, what is that you are doing, sir? You are creating a static variable S. So S is actually a T type of variable. What is S, my dear friend? It is a T. T is a data type. T is data type. We created using structure. S is a variable of type T. Now what you are doing, sir? You are assigning. And please see here, it is a string A. There is a difference between element A and a string A, sir. It is a string A. So what is that first element of this? First element is, what is the first element? A, second element is B. And here you are giving string A \0, string B \0, sir. We will call create function by using actual std structure available. Hi, sir. What is that you are trying to tell AB de Villiers for this or other problem? Okay, first let us solve. I will come to that. Now what I am doing, I am printing S dot A and S dot B. See, %S means what? String I am printing. So this A is printed here and B is printed, my dear friends. Now what I am calling, I am calling this particular function F1 whose argument is this S, copy of S. Copy of S is sent. Here it is just copy of the structure variable is sent. Now what I am doing, S dot A. See here what is happened for this particular function, one S variable is created and in that A member and B member are initialized with U and V respectively. And when you print these fellows, this U and V get printed, my dear friends. Very good. Next what I am doing, after that you go back and you again printing S dot A and S dot B. But because you just passed a copy, it will not affect the original variable. So original variable is still same S only. When you print again, AB will get printed, my dear friend. AB will get printed. Now you are calling F2, but this time you are sending address of S. So P is actually a pointer to S. And PA means this value is updated with WV and this value is updated with W, my dear friends. So that is the original variable members are updated with P, my dear friend. And when you access P arrow A means you are accessing this member which is V and here this is W, my dear friends. So the output for this particular problem is okay, very good, sir. AB, UV, AB, VW. Wonderful, sir. AB, UV, AB, VW. Suppose if I print this again, if I print here again, If I do the same print statement here, what will be output in this case, sir? Again, if I do the print statement again, what will be the output, my dear friends? It will print VW because the original original members are updated with V and W. Original members are updated with V and W, my dear friend. Very good, very good. Okay. So this is a very interesting problem, sir. If you understand it, you can say most of these ideas what we discuss are clear, my dear friends. Am I clear? So let us see this particular problem. It's also GATE question, very interesting question. Very good, Shirisha, very good. So I just need a space, so I just moved it up. So let me tell what is this. Here I created a data type called test, which is having an integer member and a character pointer member. Okay, integer member and character pointer member, and I am creating an array of this type. Okay, and what is it? ST is the name of that particular array. ST is the name of this particular array, and which is having C 1, 2, 3, 4, 5. Because each structure variable can hold one integer and one character. Can hold one integer and one character string. Character pointer means it can hold a string, my dear friends. Am I clear? So this ST actually will be having how many? 1, 2, 3, 4, 5 members. 5 variables, that is, it is an array of 5 structure variables. It is an array of 5 structure variables. Now what I am doing, this 5 is integer part of this first member and become is the string part of this particular first variable. That is, it is st0, sir. Actually it is st0. st0 is this. So this part you can call it as st0.i and this part you can call it as st0.c, my dear friends. This one you can call it as st0.c. You can use %s to print this particular part. And the next part would be, okay, let me clear this. I need some space for this. Total many members are there, no? Let me take a big one. This is 5 and this is become \0, 4, better, of course \0 you assume, sir, I am not writing every time, 6, jungle, 8, ancestors, \0, 7, brother. You can try that way, sir. See in array elements, array elements can be separated with that particular, this one also you can write, sir, there is nothing wrong. Based on that, it will be taking like that. Okay, based on that, it will be taking, because one dimensional array, you don't use the flower brackets to separate the elements. If you want, you can write that, but for one dimensional array, it is better to write all the elements separately, my dear friends. And based on this type, based on the type of the variables, this refers to st0.i, this refers to st0.c, my dear friends, and this refers to st1.i, this refers to st1.c, my dear friends. Am I clear? Yeah. So now when you do this particular fellow, this is your array, my dear friends, and in this is the array, my dear friends, array of structures. It is an array of structures, like array of integers, array of characters. It is array of structures. Array of structures. Now what I do, I create a pointer to an array of this particular type, and P contain address of ST. So P also point to the same fellow, my dear friends. P also point to the same structure, my dear friends. Am I clear? Array of structures. P also point to same array of structures. Now look here. See, we need to understand what is P. P is a pointer to a structure. So P is a pointer to integer. P plus 1 will do what, sir? It will point to the next integer. If P is a pointer to an array, P plus 1 will point to the next array. So like that we need to understand, sir. P is a pointer to a structure variable. P is a pointer to this particular structure array. Structure array means what, sir? Any array means it will point to the first memory location. So P also point to first member of the structure variable. P also point to first member of the structure variable. That is, P points to this first member, my dear friends. Like that. Now when you do P is equal to P plus 1, that is, P is moved to P plus 1. P is pointing to the next location. So P is pointing to this. So this is the effect of P is equal to P plus 1, my dear friends. Now look here. Plus plus P right arrow C. Now here this is pre-increment. Pre-increment is having lower precedence than right arrow operator. So this is equivalent to P right arrow C plus plus. That is, P right arrow C means P, this is I member and this is C member. PC means you are referring to this location, sir. This is actually PC location. Now we are incrementing this. PC plus plus means it is actually PC is equal to P right arrow C plus 1. That is, this fellow is referring to this E location, my dear friend. This fellow is referring to that E location, my dear friends. Now what you are doing, see here again, P plus plus right arrow C. P plus plus right arrow C. Here plus plus is a post increment operator. Post increment and right arrow operators are having same precedence. Post increment and right arrow operators are having same precedence and they are left to right associative. This is equivalent to P plus plus implies C. So it is post increment. First what happens? P implies C will be taken care, then P will be incremented. That means P is equal to P plus 1 will happen. Am I clear? So that is, P implies C means the string from P, that is, P implies means P right arrow C. P right arrow C is here. From here the string is printed means this entire string is printed, sir. So at this particular point, what is printed, sir? I am writing here what is printed here. Actor is printed here. From E, the end of the string is printed. Now what is happening after that? P is made to P plus 1. So P is pointing here. Now it made point to the next location, P plus 1. That is, next structure variable it points to. In the array, next structure variable it points to. Now what is this? Now what is this, sir? Star, I write here, star plus plus P right arrow C. Here right arrow will be having higher precedence. P right arrow C means this particular fellow. P right arrow C means this particular fellow. Plus plus means it is incremented. So it will be pointing to the next location. P right arrow operator pointing to the next location. You are pointing to this location. Value at that location. Star means value at that location. What is value at that location, sir? U. And you are printing that particular character means U is printed, my dear friends. U is printed, my dear friends. Am I clear? Now, after this, P is here, sir. P is here. This is only P. P right arrow C means that location is, we are directly getting that particular address. That is incremental means next location you are moving. Then the value at that location is printed, sir. Now what is happening, sir? P0. P is a pointer to an array variable. So P0 refers to this location, sir. P0 refers to this location. P0 dot I means, what is I member of that? 6 is printed. This will print 6, my dear friend. This will print 6, my dear friends. Now you say P right arrow C. Now you are printing P right arrow C. See, P right arrow C means because after increment, P right arrow C will be pointing to this location. P right arrow C will be pointing to this location. From here the string is printed means UNGLE will be printed. So here what is printed, sir? UNGLE will be printed. UNGLE will be printed. So the output of this particular program is actor U6 Angel. Yeah, that is how it happens. All of you able to follow, or you want me to repeat it? Is it clear or any doubt, sir? Is it clear or any doubt? Let me quickly give you the idea. P is initially pointing to this fellow. P is equal to P plus 1 means P plus 1 will move to this fellow. Then P right arrow C. P right arrow C means this fellow. This is P right arrow 0. But plus plus means pre-increment means it will move to the next location. That is P right arrow C is pointing to this location. and here what is happening, it is a combination of two fellows, that is P right arrow C, from there the string is printed, that is from here the string is printed, that is enter is printed. After that P is incremented, that is P plus plus, that is P is here, P is actually, okay, it is P only sir, P is equal to P plus 1 is P is here, P is incremented to P plus 1, P plus plus means what sir, P moves to the next location. Now P points to this next location, my dear friends. Now after this what is happening sir, P right arrow C means this location, that is incremented means this point to P right arrow means this will point to this location. Now value at that location means U is printed, here U is printed, my dear friends. Okay, this is U. Now what is that you are doing? P0, P0 means P is pointing to this location means this is P, P0 means this location, in that you want I member is what sir, 6 is printed here. Now what you want to print sir, P right arrow C, P right arrow C is at U it is pointing to. Now right arrow U, from there you want to print string means this ungle will be printed, this UNGLE will be printed. So this is the story for this problem, my dear friends. All of you able to follow? So the option B is the correct answer for this, option B is the correct answer for this. Oh, we are going GATE sir. Tricky and interesting and important for GATE point of view, they will not trouble you much. Yeah, so that is the idea, my dear friends. So that is about structures and functions. Now we move on to memory allocation type, dynamic memory allocations. Then we introduce this what do you call this, self-referential structures, which are useful for our self-referential structures, which are useful for our data structures, my dear friends. Basically I have to consider P right arrow C as pointer. Yeah, P right arrow C, because C is what? It is a string. C is a string. So P right arrow operator C means you are pointing to that particular string location. So what happens, the location it will be pointing to, then you get the star of that will give you the value at that particular location. Yes. Now look here. So there are different types of memory allocations, sir. We already seen the static memory allocation. Static memory allocation is in data segment, automatic allocation in runtime stack. This happens in data segment, whereas automatic allocation happens on runtime stack. And the third type is dynamic allocation, we haven't seen it, that is happening at heap memory, my dear friends. So we already know code segment, data segment, runtime stack and heap segment, my dear friends. Heap segment, my dear friends. So now let us talk about this dynamic memory allocation, how we can assign memory dynamically at runtime. Dynamic memory allocation. The process of allocating memory at time of execution or at runtime is what is known as dynamic memory allocation, my dear friends. So here we are going to allocate the memory at runtime, dynamically at runtime. That is what we call it as dynamic memory allocation, and the memory is allocated at heap, my dear friend, heap segment. The allocation and release of this memory space can be done using library functions that are declared in stdlib.h. And what are those memory functions, library functions, sir? First one is malloc. So this is the prototype of this particular malloc function. So we just need to send give the size, and it will return generic pointer, my dear friend, because using malloc you can create memory for integer pointer, character pointer or float pointer. So we do not know to which we are returning the pointer, therefore we generally use void pointer. When you are assigning, we have to do typecasting, my dear friends. Okay, yeah. Allocates block of memory, and the memory is not initialized by malloc function, my dear friends. Next function is calloc. Allocates a blocks of memory and clears it. So the block of memory is allocated and everything will be made 0, my dear friends. Everything will be cleared. The memory will be cleared, my dear friends. Realloc. See, this is the realloc function, my dear friends. It resizes the previously allocated block of memory which is created by either using malloc or calloc, my dear friends. The free function is used to free the memory which is created by any of these memory allocation functions. See, these are called memory allocation functions, sir. See, out of this malloc is used very frequently, my dear friends. Memory is used very frequently because for this you don't have to clear the memory, no. So that is the advantage. Performance wise, malloc is very good. That's why mostly malloc is used, my dear friends. Mostly we use malloc only in our programs, my dear friends. Why the memory allocation function returns value of a type void star? Okay. See here, memory allocation function is used to request a block of memory. We request a block of memory. The function has no idea what type of data we store in that particular block. Whether you are going to store integer type or float type or character type, it does not know. Therefore, what it will do? The function returns void pointer. So, you are storing integer type, no, you have to typecast integer pointer there, my dear friends. How is it possible, my dear friends? See there the variables, how they are accessed is completely different, and here is different, sir. There it happens through references. Okay, so that is references, not the addresses. We have the reference of that particular variable, not the address of the variable. Here we are going to do with addresses, my dear friends. Am I clear? Now let us try to see this malloc function. Malloc, this is the declaration of malloc, my dear friends. So size, number of bytes to be allocated. So here we are going to enter number of bytes to be allocated by malloc, my dear friends. Am I clear? Malloc returns a void pointer to the first byte of allocated memory, my dear friends. So it returns void pointer. See, this particular size is created in the heap, and the pointer or the address of that particular fellow is returned, my dear friends. Suppose you want to store integer fellow, you have to typecast with int star, my dear friend. Typecasting is important here. Typecasting need to be done, my dear friends. Typecasting need to be done because we return void star. So void star, when you are returning is, you are returning pointer to void. So what type you are storing, you have to mention explicitly by doing typecasting, my dear friends. Allocate memory contain garbage value. So the memory which is allocated by malloc will contain default garbage, my dear friends. The returned void pointer must be typecast to appropriate type of pointer, as I mentioned. So here this is what we need to do, sir. After malloc, you have to write typecast. Suppose if PTR is integer pointer, you have to write int star. If it is character pointer, you have to write char star, my dear friends. This is important. This is your responsibility. Now look here, I have a PTR which is an integer pointer. PTR, what is it? Malloc. I am allocating a size 12 bytes of memory and I typecasted it to int star. So PTR will point to a memory of 12 bytes. Of course, PTR will contain only the first address. Suppose it is 100, no, PTR means PTR points to that. That is, if you print PTR, the first memory location address you are going to get. First memory location address you are going to get. That is, PTR contain this particular address, my dear friends. Yeah. It allocates 12 contiguous bytes of memory. If int takes 4 bytes, with this we can hold 3 integers. Suppose int takes 2 bytes, with this we can hold 6 integers, my dear friends. Of course, there is an alternate way of defining malloc, my dear friends. See, instead of writing size at a time, you can say 3 into size of, you can, of course, this size of space should not be there. So size of operator is there, no? You can call size of int because you want 3 integers. You don't know size of integer is how much. Am I clear? So you can call size of int. So that will give you number, how much memory is allocated for integer into that many. How many integers you want to store? 3. You can say 3 into size of integer. Suppose you want 3 characters, 3 into size of character. You want 4 float variables, 4 into size of float. You can do like that. Yeah, same story. See, if it is integer type, int star. If it is structure type, struct star. Struct, whatever it is. Suppose the data type is student. Data type is, suppose you created a new data type, my dear friend, student. Int is a data type, you created a student data type. So you can say student star. Same story. We do this more often. Node star we write. In linked list we write node star malloc 4 into size of node. What it will create? It will create 4 nodes. It will create 4 nodes. That's it. I'll show you an example for that, my dear friends. Okay, we are getting late. Let us complete this quickly. If there is no sufficient memory available in heap, the malloc returns null. See, don't expect that malloc returns always the 12 bytes. Even if it is not available, it will fight and give you. If it is not available, it will say sorry, null will be returned. Please remember that. So therefore, always check the return value returned by malloc, my dear friends. So let us take one simple example to understand this. See, here we have to use stdlib.h. That is very important. Remember this. Now what I am doing, sir, I created a integer pointer. I is integer variable, n is integer variable. Enter the number of elements you want to store. So I want to create an array of n integers. Now see, n integers, no, n into size of integers. So I create using malloc function n into size of, that is a memory which can hold n integers I created, and I typecasted with int star. So here in this memory I can store n integers. I can now store n integers. See, up to here we only know that n into size of integers. Suppose size of integer is 4, 4n bytes will be allocated. But now with this what happens? In this 4n bytes you can store integers only. You can store what? Integers only. That is what you are explicitly mentioning. So A will contain the pointer to that particular n into size of integer, that is 4n bytes of memory. That is, starting address will be contained by this A, my dear friends. A will be pointing to that. Okay, it works just like a pointer, my dear friend. But here this is not a constant pointer, because array name is a constant pointer, but this is not a constant pointer, my dear friends. Array name cannot be pointing to something else, but this can point to something else. That is the difference between a static array and a dynamic array. This is a dynamic array. This array which we created is what is known as dynamic array. Okay, dynamic arrays again you do in a different context, sir. That not that dynamic array I am talking about. In data structures you talk about something called dynamic arrays. Array created dynamically, that's it. It is an array which is created dynamically, like that you understand. Okay, it is also static only in one sense, because in that dynamic array which you discuss in data structures concept wise, it is also static array only. This array is created dynamically. This array is created dynamically. Please call like that. Now this is your responsibility, my dear friends. This is your responsibility to check what is this value returned by the malloc function. Sometimes malloc, if memory is not allocated, it will return null. So if it is null, you have to say, Babu, memory is not available, we can't do anything. You have to mention and you have to return, my dear friends. If memory is available, that is A is not null, then you can do whatever activity you want to do it. That is in this particular memory, because total n bytes of n into 4, that is that many bytes of memory is allocated. We can store that many n integers you can store. So you can use for loop for I is equal to 0, I less than n, I plus plus. You can scan the values, sir. A plus I, the values you can scan, my dear friends. Am I clear? Like that. And you can also print those values at that particular value. Actually you can write this AI, no, this you can write it as ampersand AI also, it works. This also you can write simply AI also, it works, my dear friends. This also it works. So enter the number of elements. I entered 5 elements, and using scan function, what I am doing, sir? I am scanning 1, 5, 2, 7, 9, I am scanning, then I am printing those values, my dear friends. Calloc function. Declaration is like this, calloc, but here we have 2 arguments, sir. See, in malloc n into size we can do it now. In calloc n and size can be sent separately, my dear friends. So if it is used to allocate multiple blocks of memory, Calloc also returns null if there is not, same story, sir. If it is not available, they return null. Malloc or calloc, even realloc will do the same story, my dear friends. Am I clear? Calloc returns null if there is not sufficient memory available in heap. So there also you have to always check what is happened. See here in this calloc, what happens? The size of integer separately you are sending. The same story, if you want to do it by malloc, you can do it like the same story. You can do it by malloc like this, my dear friend. Malloc 5 into size of int. So it will be having single argument, sir. The single argument can be written like 5 into size of integer. It will take care of the same activity, my dear friends. It allocates 5 blocks of memory where each block contains 4 bytes and the starting variable is stored in the pointer variable PTR, which is of type integer. It is equivalent to the following malloc statement as I already explained. So malloc calloc differences, sir. And malloc takes one argument. The argument specifies number of blocks to be allocated, and as I told you, we can say n into size of something also you can write for this. Calloc, 2 arguments will be there. First argument specifies number of blocks or bytes. Second argument specifies size of each block. The memory allocated to malloc contains garbage value. The memory allocated by calloc initialized to 0. It clears the memory, means the memory is initialized with 0, my dear friend. That is, after allocating memory, calloc initializes it by setting all bits to 0. That is, every bit location is initialized to 0 by calloc, my dear friends. So calloc has an overhead of clearing the memory. Malloc do not have that particular overhead of clearing the memory. Malloc directly creates some garbage values will be there. So it is your responsibility, my dear friends. Realloc. See, you created some memory, later on you want to change that particular memory, my dear friends. So realloc can be used for changing that particular memory, my dear friends. So realloc, here we have first 2 arguments. First argument is pointer. See, originally pointer PTR is pointing to some location, no? So you want to extend that. So new size, suppose the original size is say 40 bytes, you want to get 60 bytes. So the new size you are going to enter, my dear friends. So used for reallocation of memory. It increase or decrease memory allocated either by malloc or calloc, my dear friends. Realloc is used to change the size of memory block without losing the old data. See, with realloc what happens, we do not lose the old data, my dear friends. Okay. So the same memory can get extended, my dear friends. Of course, suppose if it can extend here itself, it will extend. Am I clear? And the address to the new location or the new memory will be written, my dear friends. Suppose the memory is not available here, somewhere else it is available. What happens? Somewhere else the particular memory will be created. The elements are copied into that and the new address will be written by this realloc, my dear friends. Suppose if new place is not available, what it will say? It will keep the old data. Old data is not lost by using realloc, my dear friends. Please remember that. First one is pointer to block of memory that was previously allocated by malloc or calloc, and second one is new size for that particular block. So this is how we are going to write realloc function, sir. Void star, this is the prototype, and how you define int star realloc PTR. This PTR is pointing to some memory which is allocated by either malloc or calloc only. Please remember that. For realloc, initially some malloc or calloc function must be assigned some memory, sir. Then realloc can be used. Please remember that. This statement allocates the memory space of new size bytes and the starting address of this memory block is stored in the pointer variable PTR. So this PTR will contain the address of that new memory, my dear friends. The new size may be smaller or larger than the old size, my dear friends. Please remember that. If new size is larger than old, the data is not lost and newly allocated bytes are uninitialized, my dear friends. Newly allocated bytes are garbage. The starting address contained in the PTR may change if there is not sufficient memory at old address to store all the bytes consecutively. See, for example, PTR is actually pointing to some location originally, sir. Now you want to change the size. If this size is not available, what it will do? It will create this particular size at new location and PTR will point to that particular new location, my dear friends. Am I clear? This function moves the content. This old contents also will be copied back in that new memory locations, my dear friends. Am I clear? The data will not be lost. On failure, realloc also returns null, my dear friends. And in this case, the old memory is not deallocated and it remains unchanged, my dear friends. That is, suppose you want to change 40 bytes to 80 bytes, that is not available. The old data will be saved, so PTR still point to that one only. Am I clear? So that is the idea, my dear friend. Realloc returns null, so PTR will still point to the old memory only because memory is not available to increase this particular size, my dear friends. Okay, some points to be noted for this are this. This is about realloc. Hope you understand about realloc. The idea of realloc is clear. Now the final one is free function. See, free function is used to free the memory which is allocated by any of the memory allocation function, my dear friend. The dynamically allocated space is not automatically released. This is your responsibility, and for that we have this free function. And I think in C++, what is the function for freeing the memory, sir? For C++, what is the function? Because new is the function which creates the memory. What is the function which frees memory in C++? Anyone knows? It will exist till the end of the program. See, if you don't free, the memory which is created will exist till end of the program, my dear friends. Please remember that. Yeah. The function free is used to release the memory space allocated dynamically, my dear friends. Now, please remember, when the problem terminates, all the memory is released automatically by operating system, sir. Automatically, whatever memory dynamically allocated, once the program terminates, operating system releases that particular memory which is allocated dynamically, my dear friends. But it is good practice to free whenever or whatever has been allocated dynamically. Okay, after program execution completed, OS will take care of that, but it is your responsibility that whenever you use particular memory, the work is completed, it is better to deallocate that particular memory using free function, my dear friends. That is what it says. We should not free any memory location that was not allocated by these fellows. See, the free function can be used to deallocate the memory which is allocated by the memory allocation function like malloc, alloc and realloc, not other fellows, my dear friends. Please remember. Now, there are two important concepts in this regard. One is called memory leak and the other one is dangling pointer. Let us understand them. If you don't free dynamically allocated memory, this would lead to memory leak, my dear friends. See, dynamically memory you allocated, sir. If you don't free this, suppose we have a local variable pointing to dynamically allocated memory. Once the function goes out of the scope, what happens? This variable is gone. See, with this pointer you are catching this particular memory, this pointer is gone. Now you cannot access this particular memory, and this particular memory is already allocated, it cannot be allocated to anything else. So this memory is leaked. That is what we call it as memory leak, my dear friends. Example you see, void fun. So now what I created 10 into size of integer. Suppose size of integer is 4 bytes, 40 bytes of memory I allocated, my dear friends. Since PTR is local pointer variable, it will be finished automatically at the termination of the function. It is automatically terminated at the end of this particular function. PTR is gone. PTR is gone, but that particular memory is not gone, sir. That particular memory is still available, and this is what we call it as memory leak, my dear friends. But the space allocated dynamically is not deallocated. Space allocated dynamically is not deallocated automatically. So the space remains there and can't be used, leading to memory leak. Okay. So this space, whatever is there, so PTR is pointing to this particular fellow. Once you reach the end of the function, from runtime stack, the activation record of the function is removed. That is, this PTR is gone. PTR is gone, but the memory is already allocated, that is not deallocated. That will be deallocated only once the program terminates, not when the function terminates. So the memory is available, but you can't access that particular memory. So memory is leaked. Is the idea clear? To avoid memory leak, put a call to free pointer, my dear friends, at the function, at the end of the function. So at the end of the function, if you do free, whatever memory is allocated, that is freed, my dear friends. Whatever memory is allocated, that is freed. Am I going very fast or people are out? What is happening, sir? I am not seeing anyone. Okay. Yeah. Listening. Okay. Is the idea clear? Are you able to follow? See, with sir, time. Yeah, but today is last class. No, I have to complete some parts. So a little, at least I need to do the introduction for what do you call this, self-referential structure. Then I will stop, sir. Pace is understandable. Okay, fine then. To avoid memory leak, put a call at the end. So when you do it, what happens? That memory which is allocated will be deallocated, sir. But you have to be very careful. Because sometimes you free the memory, but pointer still point to that particular location. See, there are two things, pointer pointing to a memory location, pointer pointing to heap, pointer pointing to the memory which is in the heap. If pointer is gone, it leads to memory leak. If memory is gone but pointer is available, it is pointing to some location, the memory is gone, that leads to what is known as dangling pointer. So these are the two concepts, my dear friends, which are linked, my dear friends. Dangling pointer is a pointer which points to a memory location that does not exist. It points to a memory location that does not exist because you deallocated the memory. You deallocate the memory. Now look here. I have PTR and QTR, two integer pointers. PTR is allocated dynamically some particular memory, say 10 into size of integer, say 40 bytes of memory is allocated to PTR. Now you freed this PTR. PTR is freed. This will lead to what? Memory leak. This will lead to, oh sorry, what I done? So what I done, free PTR means this particular memory is deallocated, sir. This particular memory is deallocated. But PTR still pointing to that. PTR still pointing to that. So this will lead to what is known as dangling pointer, my dear friends. So now PTR is dangling pointer. Now PTR is dangling pointer. So to avoid this, what we need to do, sir? After this, you write PTR is equal to null. PTR, not small null, null. Am I clear? PTR is equal to null. You have to do it. You have to do PTR is equal to null. So what happens? PTR null means null pointer. It is not pointing to anything. It is not pointing to anything. Hope you understand. So this is how we should do it, sir. Now look here. We have integer variable a. PTR is pointing to a. See here what is happening. PTR is pointer in the main. In the main, PTR is the pointer. PTR is the pointer. Now we have a block. Let us suppose this. In this a is the variable 5. Now PTR is pointing to this particular a variable. But once you come out of this block, this particular memory is deallocated, my dear friends. The block memory is gone. The scope of block is gone. Now PTR still point to the memory which is not available, my dear friends. So this is also a dangling pointer example, my dear friend. This is also a dangling pointer example. Of course, this is an example. GATE question. After this, I will introduce self-referential structures, sir. Yeah. Now look here. There is a main function. Here we are creating memory dynamically using malloc function. See, because in the definition itself, if you write, you don't have to write int star. It directly understand it is an integer type of pointer, my dear friends. So here you don't have to write int star. If you write, there is nothing wrong, but no need of writing. If you do directly the malloc definition within malloc initialization initially only. Here you don't have to write that int star, my dear friends. Please remember that. Yeah. Now what is this particular function is doing, sir? We create malloc, that is we created an integer pointer, and for this pointer we are assigning a location, that is we are assigning dynamically 4 bytes of memory, assuming size of integer is 4. If it is null, it will return, sir. We assume that it will not be null. Malloc returns 4 bytes of memory decently. So this will generally won't happen in our program, my dear friends. We assume that. Now we are calling this particular function assign value. See, assign value is having 2 arguments. One is pointer, the other one is value. So pointer to this x. So x is this fellow now. X value is what, sir? X is dynamically allocated this particular memory. And this is initially garbage, my dear friend. Now what happens, this address is sent. So this x is actually pointing to this particular, this x is pointing to this memory location, and val is equal to 0. Star x, that is value at this x is value. What is value, sir? 0. What is the value, sir? 0, sir. Yes, sir. Sir, 10 minutes. I am planning, sir. I am also doing the same. Now what is happening, sir? This return x. So after this it will return, my dear friends. So x will be containing this particular address only. X will be containing this particular address only. Now x is address. Please remember x is address. Now what is that you are doing, sir? If x, see x is address, obviously it is not 0. So what happens, sir? It is not 0 means you enter this. Generally what people feel is x is 0.
But here x is a pointer, x is not value sir, x is a pointer. X is pointing to the location. So x is address which is non-zero, so you enter this. Again here for this x you assigned a new address, that is new size of 4 bytes. So now x point to new size of 4 bytes. Means this pointer is gone. Means this particular memory which you initially allocated is leaked. This particular memory which you analyzed or allocated initially is leaked, my dear friends. Now if it is null, no, not null, so x assigned value. So this particular function is called, and this time 10 value is assigned. So this new value is 10, my dear friends. Then you are printing that particular value at that particular pointer. So 10 is printed. Now what you are doing, you are freeing this x. So this memory is freed, my dear friends. So it looks everything is fine, but what happened is this particular memory is leaked. The question is what happened by this particular program. So compiler error, no compiler error, my dear friends. Compiler error because the comparison should made between x is equal to null. See, null is equal to x or x is equal to null does not matter sir, it can be done happily. Compile successfully, but execution may result in dangling pointer. That is wrong, na? It is not dangling pointer. Where is the dangling pointer? It results in compile successfully, but the execution may result in memory leak, my dear friend. What is happened? This particular memory is leaked, my dear friends. This memory is leaked, my dear friends. Am I clear? So the D is the answer for this problem, my dear friends. 10 is the answer, but I think D is the answer for this. Is it dangling pointer? Because this memory is also, because 2 times memory is allocated, this memory is leaked. We not de-initialize this particular memory. But after memory leak will happen, my dear friends. Which memory, which x becoming null, my dear friend? I didn't get you. See, whether null is equal to or x is equal to, we are not initializing sir, we are verifying whether x is null or not, address is null or not, we are verifying sir. X is not becoming null sir, we are verifying whether x is null or not. It is verification sir, it is just a verification. Yeah, I am in hurry actually. Okay, just let me introduce the self-referential for this. Then we can move on to what is known as the types of pointers, but let me quickly introduce this self-referential structure, sir. Now look here, sir. A structure that contains pointer to structures of its own type is known as self-referential structures. So the member is pointer to same type of structure. Member is pointer to same type of structure is what is known as self-referential structure, my dear friends. Declaration goes like this: struct tag name, data member 1, data member 2. Now look here, this is a pointer to same type. Pointer to same type. Pointer to same type. So such a structures which has a member which points to the same type of structure is what is known as self-referential structure, my dear friends. Here PTR1, PTR2 are structure pointers that can point to structure variables of type struct tag name, sir. So struct tag name is a self-referential structure. When a structure has a member that points to the same kind of structure, then it required to use struct tag name, because this struct tag name is compulsory, my dear friends. I already told you earlier. Now linked list contains consists of a chain of self-referential structures called nodes, with each node containing a pointer to the next node, my dear friends. So it is a self-referential structures. See, a node structure will be there. Node means it's a structure type where it will have different fields, but there will be one field which will be pointing to the same type of node, which will be pointing to the same type of node, which will be pointing to the same type of node. So we call them as linked list, my dear friends. We call them as linked list. So the node structure would be something like this, assuming only one data field and one link field, my dear friends. So link is the link field which point to the node of the same type. Or you can also use type def, my dear friends. Type def struct node, int data, struct node star link. you can use this node. Instead of writing struct node every time, you can simply using type def, you can create node data type. Okay, node, you can create the variables of that particular type, my dear friends. The link member has type struct node star, my dear friends. See, remember the link node, link member has type struct node star, my dear friend. It is a pointer to struct node. It is a pointer to struct node, which means it can store pointer to the same type of node. It can contain address of same type of node, my dear friends. So we created a node. We created a data type called node. This has two fields. One is data field, the other one is link field, which can contain address of the same type of node, I created two nodes, N1 and N2. N1 is one node which is having two fields, data field and link field. N2 is another node which is also having data and link field, my dear friends. N1 dot data. So N1 dot the data field is updated with value 20. The link field is given address of this. Suppose the address of this is 100 and address of this is 120, sir. The link N1 dot link is the address of this, that is this 120. 120 means it will be pointing to this fellow, my dear friends. Now what I do, N2 dot data is 30. This one data field of N2 is updated with 30 and link field is updated with null. Null means no pointer. Now I can use print N1 dot data. N1 dot data means what is printed, sir? This data, that is 20 is printed. I can print N2 dot data, that is this 30 is printed. Now using N1 I can print this 30, my dear friends. Using N1 I can print 30, my dear friends. How can you print that? See, N1 dot link is actually a pointer to this fellow. See, whenever you have a pointer, what you can do is value dot data. This need to be done, my dear friends. Value dot data need to be done. Am I clear? Because star and data, star and dot are having, because if you don't put this parenthesis, what happen? If you don't put this particular parenthesis, what happens, sir? This parenthesis is compulsory. Why this particular parenthesis is compulsory, my dear friends? If you don't put parenthesis, what happens? This link dot data will be having higher precedence. Dot will be having higher precedence than star. So if you don't put this parenthesis, what happens? If you don't put this parenthesis, this will be the meaning, my dear friend, which is somewhat different what you expect. So please be careful. You always need to put this proper parenthesis before you have to put this parenthesis before this dot operator, my dear friends, whenever you are using star, because dot is having higher precedence. Okay, yeah. Hope you understand. Or because it is a pointer, it's a pointer to this fellow, no? You can use N1 dot link data also can be done. N1 dot link arrow, right arrow, because star dot can be replaced with what, sir? Star dot can be replaced with arrow operator. That also you can do it. I think I already written that also separately. So you can do this way also, sir. N1 dot link right arrow data. This way you can write it, or this way you can write it. There are multiple ways which you can write it. I written all the possible ways for this, my dear friends. Please go through that. Am I clear? I am having 2 minutes time. Now when you print this, what happens? N1 dot data is 20, N2 dot data is 30. And this link data, that is using N1 you are accessing the data, that also gives you 30, or using right arrow operator you print, that also gives you 30, my dear friends. Now this is how we can create struct node. Okay, it is a pointer to struct node and initially which is null, my dear friends. So first null, okay, null means nothing it will point to. Just to understand, I will just given that particular notation, my dear friend. First is the variable that always point to the first node in the list, my dear friends. Setting first to null indicates that the list is initially empty, my dear friends. Creating a node requires 3 steps. Allocate memory for the node dynamically, malloc function. Store the data in the node, that is whatever node you created, for that you have to store the data in that. Then insert the node in the list wherever you want to insert, either at the end of the list, in the beginning of the list, or at the middle or after a particular node. You can do that, my dear friends. See, in linked list we understand all this more clearly. Here I am just trying to introduce the idea how you use self-referential structures, my dear friends. Now look here, this is a self-referential structure. You created a node of type new node. It's a pointer, sir. It's a new node is just a pointer to the node structure, my dear friend. It is just a pointer. Now what I do, using malloc function, I created this particular node structure dynamically in the heap, my dear friends. New node is a variable. Okay, here I already have the diagram, so let me read it. New node is a variable that is temporarily points to the node created until it is inserted into the list. Use malloc to allocate memory for the new node, saving the return value in the new node, my dear friends. So you create this particular memory using malloc function, and new node now points to the block of memory. When you do this, what happens? New node points to that particular block of memory which is created, my dear friend. Yes, 1 minute, I'll conclude it. Now what is this I am doing? New node is pointing to that particular node, my dear friends. Using new node, how can you access this data member, my dear friends? Star new node data, you can do it, or as I told you, new node right arrow operator data. Actually, this is what we use more frequently than this, my dear friends, because this is, yes, 10. So right arrow operator is very interesting one, sir. Accessing a member of structure using pointer is so common that C provides a special operator just for this particular purpose. The operator known as right arrow selection operator. Right arrow operator is combination of star and dot operators, my dear friends. It performs indirection on new node to locate the structure that it points to, then selects the value member of the structure, sir. See, that is what it will do. Right arrow operator can be used. Am I clear? We already done this. Right arrow operator produces an L value. Right arrow operator produces an L value, my dear friend. So we can use it whenever an ordinary variable would be allowed, my dear friends. It is actually representing address, my dear friends. So in the address you can store, L value means what? Address, sir. You can store the value or you can scan the values also. Just like any normal value, you can use it, sir. Okay. See, we can create it. Now what you are doing, new node data, I can assign, or you can use scanf function also for this, sir. You can use scanf function to enter the value, my dear friends. Now what I am doing, this is first I created, now I created a new node, dynamically allocate memory, and new node data I made it 10. So this is made 10, sir. New node link is first. New node link is first means null. New node link is made equal to first means null actually. That is what happens. This data is made 10, my dear friends. Now first is equal to new node. Initially first was null. Now first is equal to new node, my dear friends. First is equal to new node means not this. First is equal to new node means first will be pointing to this. Is the idea clear? Okay. So here null means, because it is null, you can do null. Null means first, then see, first this will happen, then this link will happen, my dear friends. Okay. I think I put an animation for this. Let me show you that. So what is that? New node data is 10, new node link is first, and first is equal to new node. So what happens? New node data is 10 is done, then new node link is null. First means null only, null it will happen. Then first is equal to new node, my dear friends. So this is what happens, my dear friends. So this is a simple program to create a node, my dear friends. First is a pointer to node. N1 and N2 are just nodes, my dear friend. First contains address of N1. So N1 is a node, N2 is a node which has a data field and link field. First is a pointer. So first is actually pointing the address of N1, my dear friends. N1 dot data is 20, N1 dot link is N2, and N2 dot data is 30, N2 dot link is null, my dear friends. Now what you are doing, first right arrow, because first is a pointer, no? Pointer, how can you access the data? See, with N1, how can you access the data, sir? You can access the data like N1 dot data. But using the pointer, how can you access the data, sir? First right arrow data. First right arrow data you can access. How can you access this fellow, sir? Because this is in the link field, no? First you have to go to the link field. From the link field, you are pointing to this. There is a pointer, you can say first link data, you can do it. So N1 dot link data you can do it, or first data you can do it. And how can you access this point, sir? N1 dot link right arrow data you can do it, or first link data also you can do it, my dear friends. So that will give you, this is what is first data, sir? First data is 30. N1 dot link data is sorry, first data is 20, this is 30, this is also 30, my dear friends. 20, 30, 30 will be the output. Okay. Same program, my dear friends. Of course, I just give you this because anyhow under data structures you will be learning this. You just go through this particular program, my dear friends. Okay. Yeah. There is one program, one homework problem for you. Please go through this, my dear friends. Of course, there are some types of pointers. Next time I will try to take up this types of pointer is one very interesting topic. We will try to take up all the types of pointers, how to read the pointers, we will try to understand, my dear friends. Anyhow, this particular one was ending in a hurry session. Okay. Thank you all for attending this session. Please share this particular videos to your friends. Okay. I will come up with some more problems. Please do join this particular Telegram group for updates, notes and also assignments, my dear friends. That's all for today, and we concluded our C programming here. Anyone? I think I taken the long time, so people are in hurry with their classes. Sorry. So there are one topic which I felt I not completed in this is types of pointers in little more detail. I'll take up one session in our BEP app or on YouTube, my dear friend, for this type of pointers, my dear friends. That is one thing which I felt I missed it. Shall I give these notes for you, types of pointer notes? Shall I give these types of pointer notes to you people? Bye, sir. This notes is ready, but we are in hurry because we already delayed by a lot of time. I'll give you the notes and sometime I'll discuss this topic. It's very interesting, sir. Types of pointers is very interesting. We'll try to discuss, sir. Sure. Okay. This will be total 100 slides are there in today's session, sir. I thought of completing 100 plus slides actually, but due to time constraint, we'll complete, no problem. We'll come up with some other sessions definitely. You can ask me also what are the sessions you want me to repeat or you want me to solve problems on C language and other fellows also in our Telegram group, sir. Please do share with your friends, and that's all, and we conclude C programming with this, sir. Thank you, sir. Thank you. Thank you. Thank you. Please, sir. Thank you.